Hello everybody and welcome to this Pure Insights webinar. In this session, you'll learn all about how generative AI is transforming search. Before we start, I'd like to go through a few items with you so you can get the maximum value from today's event. The presentation will last 30 minutes with a few minutes for Q&A at the end. You'll be able to text questions to the presenter at any time during the webinar via the Questions tab in the control panel, and we will address as many of these as we can during the Q&A session. The webinar is being recorded and will be available on demand on our Contents Hub afterwards. So now I'm delighted to hand over to today's presenter, Phil Lewis. So Phil, over to you.
Great, thank you, Martin, and hi everybody. Welcome to this session. I'm Phil Lewis. I'm the co-founder and CTO of Pure Insights. I'm based in the UK, and we're essentially a boutique consulting company that deploys search with embedded AI components within it in order to maximize the value for search for our customers. And one of the most interesting technologies that's really been invented over the last few months or so is really this generative AI that this session is all about. But we'll talk a little bit about what other AI technologies are also used in search today as well. So let's get started. Why now? Why is this kind of AI search revolution happening right now? If we look at a little bit of history, we look at the very first search engine that was invented, and there's been many since this, of course. It was called Smart, and it actually invented a lot of the foundational grounding technologies that we're using today in search technologies. It was a thing called TF-IDF, BM25, and vector search. And in parallel with that, there's the very first chatbot was also built in and around 1966. So 1965 for the search engine, about 1966 for the first chatbot. And it's been positively improved since then in many different ways. But in reality, there's been no real AI in search for over 53 years. Until Google came along and they invented a very transformative technology. It's called Google BERT. You've probably heard about it. It was invented at the end of 2018. And very quickly, they realized the power of this and immediately open sourced it. So within a few weeks of inventing it and releasing it, then it was already open source. And this is where we started to pick up on Google BERT and started to try to understand what we can do with Google BERT in search. And you see some applications of that in just a second. Google then went ahead and deployed this on google.com. And it essentially made the understanding of google.com, understanding really the query intent of the user, much more comprehensive than they've ever had before. We kind of always think that Google's been excellent at this, but this new transformative technology was only really added in 2019, there or thereabouts. BERT is a large language model, but it isn't a generative language model. And I'll come on to that in just a few seconds. Since then, generative AI models have been built using the same principles of Google BERT, but extending that quite heavily. And we've all heard about ChatGPT and OpenAI. That really hit us sideways when that was launched initially. How on earth can we maximize the benefit of using technology like this within a search engine? And more recently, Google Bard has also come into the fray just a few months later. So we've been very busy understanding what we can do with these technologies by clashing them or building them into search engines since then. Just to give you an idea of how quickly this technology was taken up, this is the time period that Netflix took to get to its first million users. It was about 3.5 years. If we look at the next layer down, Kickstarter, Airbnb, and Twitter was about 2 years to get to 1 million users. Then these companies took less than a year to get to 1 million users. And of course, ChatGPT only took 5 days. So 5 days of being on the market, everybody was interested in what it could do for them. And this is a really interesting kind of metric. It's not unprecedented. More recently, Meta Threads, the rival to Twitter, just took 1.5 hours to get to 1 million users. So it's not completely unprecedented, but they are impressive numbers nonetheless. Since then, of course, there's been bazillions, literally, of large language models that are flooding the market in some shape or form. Some of these are open source, like Google BERT. We see it up here in the top left-hand corner. The sizes of these circles actually represent kind of the size and the comprehensiveness of the model itself. So GPT-3, which is one of the latest models that we've been playing with, certainly GPT 3.5, and you'll see that in a few demos in just a second. That's much, much larger than BERT. And GPT-4 is, we believe, about 10 times bigger than this in size. It hasn't quite made this chart just yet, but I'll show you a chart at the end where it is on it. Some of these models are open source, some of them are not, unfortunately, so they will be behind closed doors. You can only pay for access to those services, but we're starting to see a huge proliferation of these models, both just transformative, but also generative, coming onto the market as we speak. And that's only good for us and you as clients who may want to use them. In terms of where is AI used in search today, there's a lot of places where these large language models are now appearing. So they're appearing in FAQ matching, and people also asked, I'll show you some examples of this in just a second. They're also appearing in knowledge graph answers. Google does both of these, by the way. So Google does search, but it also does FAQs. It does people also asked, and it also does knowledge graph based answers. And they also do extractive answers. So we're trying to make search engines kind of catch up with Google, or make it work like Google is our moniker here at Pure Insights. And finally, at the bottom of this chart, you can see generative answers. And this is brand new. This is something that's only really been evident, certainly for the last couple of months or so, I'd say, at this point. And all of that feeds into what we now class as a semantic search or a cognitive search system, rather than just a keyword search system that you may be using at present. So just some examples of FAQ matching. So here's the query. It just happens to be in Google. And very quickly, Google comes on and shows you different ways of expressing that same query. And that's where the large language model, with its semantic similarity algorithm, is coming into play. And of course, each of these responses, if you click on the drop down, may give you a slightly different response, a slightly different answer based on that specific question. So there is good value in understanding your question, giving you the result set, but also deep linking you to additional content at the same time. We also mentioned knowledge graphs, and large language models are, of course, embedded into these knowledge graph responses. So here on the left-hand side, where do I send a letter to Alan Norton? And you can see Google very quickly gives us an address where we can send that data. If you notice, I didn't ask for what is Alan Norton's address, but it still understood the meaning of that and give us an address. It didn't give me an email address here. It actually gave me a physical address because I'm going to send a letter. And the large language model really understands those concepts and can accommodate those in the queries. And that's why we got this boost in Google performance in 2019 or so. But we're also starting to see this capability now in regular search engines like Elasticsearch or Apache Solr or MongoDB Atlas Search, because they can also do vector-based search. And this is a demonstration system that we've built for the European Union Publications Office. And here, because this is the same data, this is the European Union Publications Office over here in Google. But if you ask the same question inside their proof of concept search, then you get exactly the same answer. Why? Because we're using the same technology that Google is, namely Google BERT here, which is just a large language model produced by Google. In addition to knowledge graph answers, Google also has a concept of featured snippets. And you can see that highlighted here. This is where the answer or the question is deeply understood by the large language model. And not only does it find the right document or the right page, but it even highlights the answer in the document. So hit highlighting normally doesn't do this. It doesn't know the answer typically. And these words are certainly not in the question. So how does it know to highlight these terms? Well, it's the large language model that's enabling us to do that. And exactly the same thing here, where we are asking the question in this way of this particular data set, again, using Elasticsearch here. Elasticsearch is ultimately, in combination with a large language model, producing the answer exactly as Google has done, even over the same content, the same physical content here as Google is. So we can provide these kinds of capabilities quite strongly on even search engines that don't fully support true questions and answers in them just yet. We can add that. So how is generative AI used today? So far, we've seen kind of regular large language models, transformer models, but generative models are a step ahead. And these kinds of images were things that hit the news maybe about 6 months ago, maybe even up to a year ago now. And all of these images are essentially fake, apart from this one down here. um, and the Pope really did not wear that coat. The AI, or the generative AI, has actually built that image from a prompt, and the prompt has just asked for a picture of the Pope in some kind of designer puffy jacket, and that's what the generative AI is generated from that text prompt. Here, in a recently launched movie, we can see that this face has been de-aged, essentially. He was really doing the acting at this point, but they were compositing a different face, or a younger version of that face, in a generative way on top. And it looks really natural and really quite interesting use of this technology. But it's not just about images. We've also seen evidence of applications whereby we can listen to your voice, and within just a few seconds, we can take over the conversation, and essentially it will sound like you. Just in a few seconds of your own voice, the new generative AI technology can understand all of the signals that you've got within your voice itself and mimic that to the end users. Here we have a generative music, and of course these are all audio generative elements. And finally, before we get into how we use generative AI in search, you can see some really spectacular applications of generative AI, where the AI has generated this chair to be minimum weight but maximum strength. In this case, the AI has generated this jet engine to be maximum airflow with minimum temperatures. And up here, we can see it's taken a look at this object and said, I can do better than that, and essentially redesigned the part for maximum strength with minimum materials being used within it. So really, stunning uses of generative AI. So how are we using it in text, in the text world today? Well, ultimately, it really started off with some AI that can do code generation. So this is an example of a prompt that a programmer might put into these AI-based systems. Write me a little program using Python to do these particular tasks. And then the output from that is the actual program itself. So it's a really, really interesting use case. And then we thought, well, how else do we use this kind of text generation capability more closely related to the search engine experience? So first of all, here we have an example of a long form document. This is a PDF document. It actually consists of about 10 pages. I'm only showing the first two here. And we want to get a feeling for what this document is about. So what we've done is we've asked the AI system to generate a summary of this document. So I can essentially speed read the main threads of thought that are contained within that particular document. And this can enable us to understand what the format of that document is, really what it's talking about. Typically, if I read this, if I do a speed read of this and then say, oh, that's actually a very interesting document for me, then of course I would go and reread the actual main content itself. I wouldn't just stop here at reading the summary. I would typically read that content. But this could save potentially significant cost in humans generating these document summaries. Another example in the e-commerce space is where there is a lot of review-based data in and around products, and we've asked the AI here to kind of summarize the discrete reviews. So here we have a number of reviews, maybe 10 or 20 reviews. Some of them are 4-star, some of them are 5-star, some of them are 2-star, as you can see down here. But what are the main threads that these reviews are talking about? So we can see here that what the reviewers mainly like about the product is summarized there. What they mainly dislike about the product as a collection rather than an individual is discussed here. What they think about the value of that product is discussed here. And this could be a new page which is generated. Many websites have this reviews section built in, but maybe we could generate one of these pages completely automatically, which changes over time as new reviews get updated, so that it gives a speed read essentially of the information that's in the review data. And another application that we've seen a lot of traction for in the market, again in the e-commerce space, the challenge is you've got a whole bunch of metadata about a product. but it is very sparse. It's just essentially metadata. You can see the type of product that this is. It has a specific name. It has a specific type. It has a bunch of features which are interesting. And we've asked the AI to write essentially a product description about that product with only this data. This is literally the only data. That little block of text there is all it knew about. But on the right-hand side, it has generated this by understanding what user upgradable firmware means, by understanding what servo evolution technology means, and then writing paragraphs and paragraphs about that product so that it will hopefully resonate with end users. So again, significantly reducing the cost of putting large scale sets of products on your product catalog. And I'll show you a live demonstration of this particular demo here. This is where we're using generative AI to answer questions posed to a search engine. So here, typically, we normally see keyword types of queries within this, but Google is kind of training us to be able to ask specific questions of Google, and Elasticsearch and Solr and various other search engines out there on the market, they can't really answer the question. They just take you to a list of documents, which hopefully you can then find the answer to your question within them. But with generative AI, we can essentially do a speed read of these results in the AI model itself, and then fine tune an output which is specific to that specific question. So I'll show you a couple of examples of that working live in just a second, but it's really starting to change the way we interact with search engines quite dramatically. There are some potential gotchas though with generative AI, and I do want to touch on these just to show you that whilst the general understanding of these AI models is very scary, we have put things in place to mitigate against this scary world of generative AI. So some of the things that are potential problems are it's not trained on my data. How can it possibly answer a question on my data? It's a closed book response, and the closed book is essentially the internet. And it's not even read my content. So how can it answer a question on my content? Well, we've kind of solved that problem now, and I'll show you how we do that in just a second. Some of the answers are hallucinated. We get incorrect answers from the data, and that's, there's several reasons why that's happening, which I'll go into in just a second. But this is also now a problem that we've pretty much solved because we're actually using your content, your internally generated content, as the master of truth rather than the internet. And I'll show you how we do that in just a second. When they do give an answer, these AI models don't even know that they're giving you a wrong answer. They have no kind of internal guilt or internal feelings about how they are answering you, and they honestly don't know whether they're giving you the right answer or not. But again, I think we've solved that problem by deploying these AI models in very different ways to the ways that you're seeing being used in the press today. Of course, these AI models do suffer from stolen data issues. Some of these models will provide answers from maybe secure data or what people thought was secure data, and that's very sensitive. There are obviously copyright cases and legal exposure cases taking place right now because the large language model has uttered a sentence from a document or a book when it shouldn't have. And these are all things, again, which we have a solution to when processing your own content. So sensitive information disclosure is another issue whereby the data is in the large language model. You ask it a question. It does not know that Phil is okay to know that answer, but Martin isn't okay to know that answer. So these are things, again, that we've solved within this scenario, all the way through to biases and data provenance and limited transparency. So let's show you why. So here we have the large language model. It's been trained on pretty much everything that's available on the internet in an open way, including some not quite so open data sources. But there were three things that came out of that large language model. The first thing it did is it tried to understand the language itself. How is the language constructed? What are the terms? What are the verbs? What are the nouns? What are all? How do you stem? How do you convert processing to process, so we know what it means? All of those good things are handled by the large language model for us. The other thing is that it extracted facts, and of course, because it's the internet, it extracted facts from potentially very conflicting viewpoints. It also potentially has seen several untruths, if not lots of untruths out there on the internet. And it's very hard for a large language model to work out what is true, what is not true. So in reality, this macro viewpoint, this high level view of data is kind of gray. It's a kind of gray area. There is no black and white. It's always gray, essentially. And that's not a good scenario. So asking the large language model to provide you with an answer from its closed book knowledge sometimes will work, sometimes it may not work as well as you had hoped. The good news is that there is lots of subjects covered within that content understanding model, but there are some biases injected as part of that as well. The trick, if you like, to using these large language models in a secure way and in a way that does not provide bias is to inject a search engine between the large language model and your data. So when facts are requested from that data, or whether you're trying to do content understanding against that data, the search engine steps in the way. And this is where we do document security filtering. This is where we tell the large language model, do not answer from data from the internet, only answer from my corporate data. And therefore you have a much more accurate set of data that you're answering over. So we deliberately break that connection to the internet knowledge that it has. And we only allow it to answer from your enterprise data, but we do rely on its language understanding that it got from the internet, and that's now known as an open book knowledge system. So the open books, of course, all your content articles that are of interest to you. And at any given time, the large language model can use those very, very quickly with a search engine as a reference in order to answer any particular question. So I'll show you some examples of that in just a second. And the visual kind of gives you the clue here. All of these points are essentially negated. The visual in the first one looked a bit scary, but now it's looking like a much nicer place to be by using these generative AI models across your own data. The majority of those issues have been pretty much solved. So let's give you a quick demonstration. My first demo is of an enterprise search solution. And in this case, I am searching over enterprise data from Pure Insights. So I'm going to ask it a quick question here, and we're going to ask it, do you have an office in CR? And we immediately get a set of results back from the search engine. This is an Elasticsearch set of results. You saw it was sub-second, in fact, 8 milliseconds for that response to come back. And then it took a little while, maybe a second or two, for it to consider that question in the AI layer and to provide us with an answer. And it comes back with that answer directly. So I don't really need to open this document and find out where the office is. It actually has told us that. At the same time as giving us that answer, it's thought about other questions which may be interesting to you as a user based on this question. So these are similar questions. The AI has generated these. These are not questions that have ever been asked before by another human on this website. So you don't need that log data in order to generate these interesting interactions with the system. But the AI has generated these based on what you've asked before and what was the response that it just found from the underlying search engine. So I'll just ask it another couple of questions and then I'll switch context. So here I'm asking it kind of a technical question. So what is a hydrator? And Pure Insights have a very specific meaning to hydration. And hydration to us has got nothing really to do with water, but it's all to do with a component that takes data from one system and then flushes that data into another system by hydrating it with the knowledge that we've expected or extracted from those original data assets. So again, we get a direct response, a technical response to that question. If I then change the question again to be a little bit more subjective, is OpenSearch better than Solr? And in this case, this particular model didn't really have an opinion. Now this model is GPT 3.5 Turbo, which is the precursor to GPT-4. So I'm just going to switch to GPT-4, and I'm going to ask that same question and see if it has a slightly better understanding of the data assets that we have. So there is definitely a difference between these large language models. Some of them will do a better job than others. And if you notice, this particular model took a little bit longer to consider its answer, but it does provide this more objective, or sorry, subjective response, where it's arguing the case for open search, it's arguing the case for Solr, giving you positives about open search, giving you positives about Solr, and really deep linking you into that content. Okay, so this is using these large language models in combination with Elasticsearch to do the vector search piece very, very quickly over enterprise data. Let's see how that might work in an e-commerce case. So I just want to do a couple of queries here. Maybe if I did a query something like this, what is the slew rate of a mono X200? So again, this is kind of a fact-finding question. Instantly, the search engine has come back and said, I think you need to read this document on the Mono X200. And of course, I can click on it and it will take us to the website. And maybe I can find the slew rate right there on the page. But because the AI system also understood that question, within a second or so, we get a response about that answer. Let me just ask that question again. And we get that answer back in just a second or so, specifically from that. And what's happened there is the AI has sped read or done a speed read of these results, and it said, well, I can help you with that specific question, and I've already found it on the page, and here it is. Here is that answer. But it doesn't need to be a product question. It could be just a general type of question, maybe something that technical support, or customer service may help with. How much do you charge for servicing of your products? So again, the system has done a very quick speed read of these results, and come up with what it thinks is an appropriate answer for that response. Couple more questions, and I'll show you something really, really interesting. In fact, I might do that right now. Let's do a quick search here on what is a QXR upgrade card. So this is a very naive question. We've got some data which tells us a little bit about that, but ultimately the system is coming back and giving us the answer of what exactly this QXR upgrade card really is. And if you notice, I'm using GPT 3.5 Turbo here, but I'm also asking it for the response to be in English and the answer style to be for an audio file. And now maybe I'm not an audiophile, maybe I'm a technophobe. And if you look at this, there's lots of techno speak gobbledygook within this answer. But I'm now going to ask the same question and tell it, well, I'm a technophobe, so please resist on giving me techno babble. And here we can see that the answer has been regenerated. So this is not an extraction from a document. This is truly a regenerated answer based on the target audience of interest. And I could even, this is a silly request, I know, but I could even say, what is a QXR upgrade card? And please explain that to a child. And you can see that the response has been dumbed down quite significantly to help a child understand what this object could be. And lastly, before we just jump back in for the last few minutes, we may even ask questions in different languages. So I'm going to go back to audio file, and here I am going to use the GPT-4 model, and I'm going to ask the question, what is the difference between a DAC XP and a DAC XP Plus? And what's interesting about this is it accepted the question in Spanish, even though all of the content available to us is only in English. So it still understood the question, and it still found the right articles, essentially, or right products that can answer this question, and it's regurgitated that answer in English. Now, of course, I don't need to answer in English. I can answer directly in Spanish, which is a bit of a feat because the question is in Spanish, the answer requested is in Spanish, but all of the data that it's processing is actually in English. So this Spanish answer, which we'll get in just a second, fingers crossed, is, there you go, is coming directly from the generative AI model. And we can go really crazy with this. If I just do a really quick response here so it's a Spanish question for an audio file over English content only, and I want the answer to be output in Greek. Nobody, I don't think, would ever do that in the real world, but it is something that these large language generative models can cope with. It's taken a few seconds here, but there we get that response in Greek. Okay, so for the last minute or so, I'm going to jump back into this presentation and just show you what the next steps are, or the next level of language models are. We can see that GPT-4 is a very large model, and I was bouncing between 3.5 and GPT-4 here, but there are others coming. We know that OpenAI is already working on GPT-5. We know that Google, DeepMind, and various other organizations out there are still working on additional language models, and this is just going to benefit us in ways we probably can't even imagine right now. But the reality is that there is always a new model coming, but you can still use these models right now, as we've just seen in that last demonstration. So in summary, large language models are literally white hot at the moment. We think this may settle down in time once the large language models have stabilized and kind of do everything that everybody wants. There's no need to build another one when it already does everything that you need it to do. But all of the major players are playing with these large language models now and building these large language models so that we can use them in our everyday applications. We truly believe that generative AI will change the way that you interact with documents and corporate knowledge, from document finding, traditional search, keyword search, essentially, through to questions and answers, as you've just seen. And we know this is a fact because there is a huge uptake in questions about demonstrators and prototypes. And we realize these are super critical right now because leadership are asking these types of questions. How can my business benefit from these large language models now? And we would love to talk to you about any potential use cases that you may have where we can help build you an application using these types of large language models today. So with that, I'd like to draw a close to the webinar, and good luck, and thank you very much for attending this one, and hopefully we'll see you on the next one. Thanks very much.